I think we should go ahead and get started then, Kyle.
Okay.
Yeah, let's get started.
All right. Okay. So has anyone completed the lab? Would you want to go ahead and um, show the solution if anybody has? If not, we can take it in the at the end of the session today. Okay. So right. So for today's class, we'll be going over 2 to 3 notebooks and one and start with the second lab, and we can try to get started with the third lab as well. So this is what we'd like to do today. So in this session, we'll start with working with strings. Let me choose my environment. Something weird is happening. Okay. Yeah. So when we're working with strings in pandas, generally if you pass in a list, it automatically gets converted into an object data type. So the recommended way to store, if you know that the data type of this particular series or a column is string, it would be ideal to set explicitly as a string data type. Why? Because when you're using some string methods, uh, there's less chance of it malfunctioning or not giving the right type of output that you would expect. So there are some minor differences between an object and a string data type. So that you can refer to here. So this is just this would be generic, but this would make your data type more specific. So it's always better to do that. Now, when you're so far we've been looking at numerical columns. So when we're looking at string columns, you can access some methods to manipulate strings, and you can access them through this dot string accessor. So these string methods are very similar to the built-in Python string methods, and they have very similar names as well. So to proceed, we will look at one specific data set, which is a weather data set, and we have downloaded it from here. And we are going to use a subset of this data collected from New Orleans Lakefront Airport Station. So there are 4 variables in this data set, right? So we're going to have station, the name, date, average wind speed, precipitation, maximum temperature, and minimum and maximum temperatures. So we load the data set as usual using read CSV, and we are viewing the data set. We're taking a glimpse of the first few rows. Now, you can easily use the string methods by just saying dot string and applying the Python built-in string methods that it becomes easy to use them. So you just say, if you want to change the case of a particular string, all you need to do is dot string dot lower. It will change it for all the values in your column. Or if you wanted to capitalize, right? Then you can also reset the column names this way, right? So this is what we've done here. Instead of column, you can also access the column names by saying weather df dot columns. So this would give you the columns as a series, panda series. Then since it's a panda series, you can use the string accessor. So we have done that to get get these names in a capitalized format, and then we're just replacing the column names with the modified strings, right? So after that, we see that we have in this column New Orleans Lakefront Airport, comma, LAUS. So we may want to split this into two columns, right? So we could use something called split, and split would split on a particular separator. So we can give the separator, and it will convert the string into a list of strings, all separated by the particular separator. Now, you may want to put the first item of the list in one column and the second in another column. And to do that, you have a very easy, just add an additional parameter, and you say expand equals true. Then you have two columns, right? So it becomes easy to split it. Now, how do you add it back to your data frame? You just take the first column, and then you take the second column and add new columns to your data frame, right? So why 0 and 1? Because actually the column names are 0 and 1 here. So that's why we say 0 and 1. Then we can replace LA with Louisiana in the state column, right? So simply, if you want to replace text, this also is very simple. You can just say with the string that you want to replace, the original string and the new string. You could also use regular expressions, and regex is a whole topic on its own. So we won't be covering regular expressions here, but we can use it, right? So, and you can use this to start learning in regex 101 if you don't already know. So you could use that.
So regex to modify any of the column names or anything, absolutely
Yes.
anything.
Yes.
Okay. String manipulation.
Yes. So then we have concatenating to, so let's say you want to bring it back together in one single column. That also you can do by saying whether df, you take the column, use the string accessor, and then you say cat, and then you pass in another column, and you can pass in a separator as well. So this would concatenate two columns together and put them in the same column. So now we have one series from two different series. Right, so then we can also do some extraction. This will come in handy. So let's say that you have a series where, let's say, F7 refers to female and 7 refers to age. So we have a series with, the sex and the age put together in one group. So we could actually separate this out using some regular expressions, right? So here are two captcha groups. So we have one group where we are trying to select either M or F. Then anything that follows it, any digits that follows it is captured in the second group. So each group will, when we use this, right? So when we take this particular series, take a string and extract, we can actually what would happen is each group gets captured in a separate column. So we get two columns with with one with the gender and the other with the age.
So sorry, Kyle. We started with a what you call series, and as soon as we did that, to extract, it became a data frame.
Yeah.
No, what did it become?
Yes, it is a data frame.
It became a data frame. Okay,
Mm-hmm.
got it. Interesting. So one above the sex underscore age, at that time it was a series.
Yes, it is a pandas series,
Uh-huh.
and this is a pandas data frame, which is just
So the same variable is now pointing to a data frame.
yes.
Got it.
So that is because I have assigned it that way.
Assigned it that way.
Yeah.
Correct. Yeah, yeah.
Right. So then we could, in case we want to wrangle with some more complicated groups like this, that is also possible. We have a range of age groups, right? So
Mm-hmm.
in this case, yes, the regex will be a little bit more complicated. So we're going to do some. We can skip this. If you want, you can read this in a little bit detail to understand the different capture groups that we are trying to use, right? And eventually, we're just trying to capture 3 items, right? So one is the gender, male or female. Then we want to capture, um, wait, yes, so we want to capture the range, right? We want to capture the range, or we want to capture the other type where it is 30 plus or something, right? So if there are 0 to 10, 10 to 20, this is one type, and the other type is 30 plus, 40 plus, or whatever. So
Mm-hmm.
both combined together, we get in the first column,
Mm-hmm.
right? So this is what we're trying to capture here. And so and this would become regex is a very handy tool, and if you get familiar with it, you can it becomes very easy to manipulate string. So that brings us to the end of lesson 5. So we have a short lab for this, which is the okay, right? So there is a data set. Um,
2 labs.
yeah, this is lab
2.
2.
Okay.
We've lab 1 was the one we talked about yesterday. So this one, you can just go through this, where we have one data set, all books, and it's actually in the data set folder. So you can load the data set, check its shape, uh, look at the head and tail, describe. Then at this point, we're going to, you'll first have to look at the data set to see how the column names are. And we're going to do some splitting, right? So some simple splitting into book and chapter. So we have the book and chapter name put together. So we're going to split it, right? And then drop some columns. Also, we're going to remove the chapter name from a particular column. So we can spend some time on this if you would like to. We can spend, like, I guess, some 30 minutes on this lab before proceeding. So this will come in handy for the next lesson as well, which is tidy data. So those who haven't set up their environment, this will be a good time, and you can get started on this lab. So basically, this course would be most useful if where we work on these small problems together, so that you become comfortable with handling data in Python. So we can take some time to work on the labs. Is that all right? So anyone has any issues setting up the environment, or has everyone done it? You can show a thumbs up so that we'll
Yeah.
know that you're ready.
Kyle, the source is the local, whatever the data set is local one, right? Whatever the data set.
Yes.
Okay.
Yes.
So basically we need to read that file, how we were doing yesterday, the same way we need to read that, right?
Yes. Let me check though. Okay, so no, it's not here in this local folder. It's actually in our GitHub repository. So
Okay.
how you would load it is you would say support
The URL.
vectors.
Yeah,
Yes.
the URL. Okay.
Yes. URL plus the file name, which is
Yeah.
this.
Yesterday we have the raw.git post something, we have that, or it's a different location?
This it's the
Pretty
same.
much same, right? Yeah. Only file name is different.
Yes.
Thank you.
Also, if you have any questions, you can post in our Discord channel.
So, Kyle, under the datasets folder, we have all the CSVs, right?
Yeah,
Which
there are some CSVs as well, but we're not using all of them. Like that, those we are using for other labs. So we
Okay.
have like 3 sources for data sets. We have some in the URL, some locally, and some in a database. So we'll be trying to get them from different sources.
Oh, okay. So we are essentially adding file name CSV to that.
Yes.
Okay.
Not file name. Yeah, this is the file name.
To ask the question, where do we post it in the Discord? There is a data wrangling channel. We can put our question there, or
I have shared a link in the Zoom chat. Are you able to access it? A Discord link. I have shared a link in the Zoom. Sorry?
I'm in the Discord, but where to put it? The question
No,
is
no. I posted a particular link in the Zoom chat.
Okay, got it. I clicked on that.
If you go to the channel,
that is under the data wrangling setup issues.
Yes.
Yeah, I'll put it there. Thank you.
Sure.
You can create a new post if it's related to something else as well, right? So, or if you want to continue on this particular chat, you can do that.
Yeah, sure. Thank you.
Yeah. So we'll start the session back at in India 8:20. That would be 7:50, right? 7:50.
Correct.
No, our
Yes.
time is 7:27. Maybe you can just give the time so that another 15 minutes, so that'll be easy for, because so many people are in different locations, right? So here I'm in PST time. It's a around 7:30, around 7:27.
Okay. So yes, like some 20 minutes we can give for this, and let's see. Okay, so we're getting a question. I am all. Oh, okay. So this is
It's a poll I created.
Oh,
Kyle, yeah,
oh,
I created.
nice. Thanks, Rahi.
Yeah, sure.
whenever you say a series is like a text form, right? How do we get that? I thought a series is kind of completely a sentence, right? Or
A panda series. Are
okay,
you talking
but
about that?
no, I'm talking about. I just opened the CSV file. It's like it's complete lot of text there. Okay, it's
Okay.
like comma separated text CSV file,
Mm-hmm.
right?
Mm-hmm.
So when you say shape it, it's like in the matrix form or comma separated, or how that is. I got the shape
Okay.
of around. Maybe you can explain later. Around text. So
Okay.
590
No,
by
it's okay.
590 by 8267. The shape is giving me.
Okay. So there are if you do the df.shape, you're getting that?
Yeah.
Okay. So the
It's
first value tells me
590.
the number of rows, and the second value tells the number of columns.
Okay. That is like.
Well, I'm not getting the URL right. Is it just a SVC, SV rep path plus
Maybe I can
file
copy
name
that URL.
CSV?
Let me copy.
Yes.
I'm in different computer. Sorry.
And then df equals pd dot read underscore CSV.
Mm-hmm.
URL, it's bombing out. I don't know why. HTTP error. So the path name is not correct, probably.
You want
Oh, all books. That's the name. Okay, got it. I forgot about it.
It works. Okay, so several people haven't responded to the poll. Are you struggling or with the setup, or is it done? So do let us know so that we can help you.
when you say split function is specific to any name and try that. What do you? Or there's one option called split here. Just split. You unnamed the split.
Mm-hmm.
That's okay.
How do we look at the top of it? In the first row, I mean the headers.
How do we look at it?
At the top of the data
Okay.
frame, I mean the column names.
Yep. So it's just dot head.
Just dot head.
Mm-hmm. Yeah.
I'm getting garbled stuff, looks like. It read 590 rows, 8267 columns.
Okay.
Is that correct?
I would have to check. Anybody else?
That's right.
Damu, I
That's right.
think.
Kyle,
That's right.
for
Yeah.
me,
For
it's not even
8267, I got 590, 8267.
8267. That's correct.
Yep.
Okay.
Yes, Dilawar.
For me, yeah, even though yesterday I ran the pip install requirements, new package, everything, it's not even recognizing pandas.
Okay. Firstly, did you make sure that the correct environment is selected?
Yeah, yeah.
Okay.
My car shows me the new environment which I created. And when I tried to install yesterday, it errored out only for that Pydantic package. The rest of all got installed.
Okay. So you installed it in the correct environment, like you did conda
Yes.
activate
Yeah, correct.
Okay. So this you have done. Then when you open your notebook, you
Lab 2,
have
yeah, lab 2. When I go to lab 2 and run the first line.
no. Have you selected this environment, the kernel? Like
Yeah, it shows me the kernel is data wrangling in whatever I
okay,
created. Yeah.
okay. So now which cell is causing the issue?
The first cell in lab 2. Import first cell itself I run that.
If you run it, it is not working.
Yeah, it shows that
Okay.
no module name pandas.
Then likely you have not. Can you do one thing? Can you like in your terminal activate dwn, okay, and just type in Python, and let's just do import pandas. This should work.
Can you posting somewhere in Discord or?
I'm just on my screen, like
One
it's
second. Oh, sorry. 1 second. Yeah. What is it?
just
Import
type
pandas.
in
Conda
first
activate my environment, right?
yes.
My environment. Okay.
Someone has said that they're struggling. Is that you or?
Yeah, that was me.
Okay.
First activate my environment again in the kernel. Okay.
Why the header name is unnamed :0? This is what you have planned. So when I do the data frame, because it comes with unnamed, it is because when I do unnamed :0.str, something problem in the thing. No, even the data set is unnamed :0.
Right, got
Correct.
it.
Yeah. So when we do a .str, after that it will not give you the one of the thing called split unnamed :0. Something header is issue there. That file. I mean, that is the plan. I mean, that's
This is the column name, is it? Like
yeah. Even data set is
okay.
the same name, column name. So when I do a split of that, there is a space there. Definitely it will not work, right?
Okay, let's view the data set.
Yeah, the data set is pretty. It looks a little garbled, but you probably know it better.
If you run it, you will see that because something header issue there. Header issue there.
Kyle, when I do it, it says no module name pandas. Even
okay, so then you come out, do exit, and do pip install -r requirements .text. So it is likely that you did not activate the environment before installing, because requirements.txt has pandas. It should work.
Yeah, when I in the install when I did this, I got one error. Okay.
Well, exactly what are we doing with the split? Are we trying to remove the .0? Are we trying to rename the column?
We are trying to, in this column, we're trying to separate it into two columns. One, the religion, I'm sorry, the book name, and then the chapter. So we want two columns.
Okay, so essentially you would do it within with the regex then.
You could, but you could also use a simpler technique, which
Okay.
we discussed.
But what would the column headers be in that case? Unnamed in one and 0 in the other?
Yeah, you can check it, like try it out.
Okay. Okay. No, because what I'm trying to say is that it's not consistent in the actual values that are in there. There is an underscore,
The
but in
column
the
name, let's say, let's say this data set is not good. Somehow it's the values are,
No, I
this
understood.
shouldn't
I
be this.
understood
Yeah.
what we needs to be done with the values. I don't know
Uh-huh.
what needs to be done with the column name.
Okay, maybe first change the column name into something else. The first step, you could just do that. Let's
Okay.
if it is, you can, let's say right now it is unnamed 0. Eventually, actually you would want to separate it out into 2 columns called book and chapter.
Got it. So let's just do it in the book and chapter then.
Yeah,
Yeah.
that's end goal.
First.
But I don't know how to change the column name. And maybe
okay.
that's that's what you expected. How to
Yes.
change? Okay.
Yes, you can change the column name.
Yeah, I don't know that.
But we will have to
See, we may not have discussed this, or we may have discussed this earlier, but anyway, you can always refer to the documentation.
Yeah.
Just
Yes, indeed.
So Dilavar, is the installation complete?
Yeah, install complete now.
Okay, now let's just do this again and try import pandas.
Yeah.
Is it working?
When I type in the load the dataset first column import pandas speed, it cannot resolve that pandas. So
let's check in the terminal first. If you start a Python session and say import pandas.
Okay.
Is it working?
What I did this morning, like I was closed all the thing and I started freshly.
Oh,
it started
that
working.
could also be.
This morning I faced that NumPy was running.
For me it says could not open Python starter. No such file or directory. Python files Python rc.py.
Okay, do you want to share your screen? Let's just. Okay, somebody else has also said that they need help. Could you post your issue? We can help you.
Share my screen. I joined Zoom from a browser.
Okay.
Not see option to share.
You don't see? Could you in your keyboard do Alt S?
I'm in a Mac, so Alt S works.
Or Command S, I think.
Okay, let me try Command S. No, just save.
What?
It goes for the save option.
Oh, okay. What is the alternative to Alt in Mac?
Yeah, I'm just trying. When I click on more, it doesn't allow me to. It doesn't give me any option to share. Because since it's joined from.
Rahi, can you check this? Who can start sharing? Anyone else?
He's not able to share his screen, but it's on all participant mode. He should be. What's that? What is this? Star Shift +4. No, in Mac.
Maybe you can post a screenshot in Discord, and please do just close your VS Code and start it again. Sometimes that is all the issue is.
Dilavar, did your pip install go through without errors?
Yeah, it went in. The pip install our requirements. It installed all the extensions.
Ran without any issues.
Yeah, it did.
Okay, and import pandas also seems to be working on your command line.
Command line, no.
This is mine.
Oh, okay.
So,
oh, okay.
It said could not open Python startup. This is the error I get.
But on command line, is it working? This one, whatever she's showing, Kyle is showing. Did you try that? Where you are just trying to do a Python and then do import pandas.
Yeah. I went to the Python mode, and then when I try to click import pandas, that's where I get an error.
Even now it is giving, even after doing pip install of requirements.
Yeah.
Strange.
It's giving me an error. File not found. Maybe it is. Earlier I had a different environment, and I now created new also. This is the error I'm getting. I'm posting it. If we go on.
sure.
This has nothing to do with pandas. It is your Python environment itself.
So, I mean, it got messed up. Earlier there was another environment, right? Now I created a new environment. So when I created a new environment, the environment is good, but
Kyle, maybe you unshare your screen. On the top of your web page in the Zoom, you see new share next to polls. Mute, stop video, security, participants, chat, polls, new share, pause share, donate, apps. You must be seeing these icons.
No, I'm not seeing.
No, he Dilavar.
Okay.
Since he is on web.
Yeah, I'm on web.
Yeah. So you see these options? Mute, stop video, security, participants, chat, polls, then new share.
Yeah, participants, chat, reactions, AI campaign, more. That's all I see. I don't see anything else.
More. Click on more.
Yeah, click on more. It's only captions, whiteboard, settings, return to defaults for me.
No share option?
Yeah.
Strange, huh? Maybe you quickly download the app on your system and join from there.
But anyway, the error that he has posted on the Zoom chat, I don't know, that yours seems to be a more complex issue. Maybe we need to get into a separate Zoom session to figure out your issue, because it's not a standard issue, whatever you're posting.
Yeah.
It is something with a Python environment itself. You may have to, I don't know, reinstall Python. I'm not sure. This is not to do with any pandas or any specific package. You'll probably have this issue with any package.
No, this is only up for this new environment is happening. I'll try to restart. Also,
Okay, so has anyone been able to complete this step?
Still working. I just changed the column name.
Nice.
Slow. Slow.
No, sure.
Anyone worked on the first lab? So if you have, you can share your
Okay. Kyle, I think now it worked for me. I just made a restart. Hard restart on the kernel. Hard restart on the kernel. So pandas is now getting import
Nice.
pandas is getting
Okay,
recognized.
so Dilaver, this is Dilaver, right?
Yeah.
Okay,
What did you do? You did
I
this
didn't do
restart, is it?
anything. So what I did was on the top right on VS Code where you have a after run all
Yeah.
against your
Okay, you
notebook.
just
There is a
restarted.
restart,
Okay.
right? I clicked on
Yes.
restart the Juniper kernel. Then it started recognizing. I do not
Nice.
know what the reason is, but after that, when I run the cell for import pandas and numpy, now I could
Okay.
the first cell load before the data set load, I could see that. Yeah.
Okay,
Can you repeat that? How did you go to the all restart?
So, Guru, if you go
Here.
in that Juniper notebook, on the top you'll see code, markdown, run all. After that, there is a restart kernel.
I'm pointing to it on my shared screen, so you can
Guru,
check.
I couldn't share. Yeah, that is the one exact part. That's restart, Guru. If you click on that restart,
Okay.
then it starts working.
But did you
I do not know why.
try on the terminal? You had the same issue, is it?
Yeah, Python. So earlier, now after that, it started working. Before restart, since I had a earlier another environment where I also had pandas code there a little bit, so it was getting confused. It looks like if you see that the chat in the chat window, I posted the path right. It couldn't locate the path. I do not know what the reason was. Yeah, but restart
You
kernel.
created.
Then
Okay.
Even after restart, it's not. So is it something like we need to restart the entire Visual Studio?
Maybe you close once the Visual Studio Guru and then try to restart. But your pip install went through good, right?
Yes. Pip install with the requirement tests, everything went through, and then I was able to activate the
environment as well.
Yeah, environment. The problem is not coming on the.
Firstly, you have to activate the environment before you do the pip install. Did you do that?
Yeah,
correct.
Okay.
Did that like the conda activate?
Yeah. Okay. And I'd say yes. Close VS Code and start it again, and run the first cell.
The first one is yeah. And here the path is there, Kyle. The second one, load the data set, panda.read CSV, and you're giving what?
So this we are passing in the repository path. So this syntax, are you familiar with, or do you want me to explain this?
I'm not.
Okay, got it. So this is a formatted string where you can pass in a variable and the value of the variable is used in the string. So
correct. So format and you gave that path. Oh, you are concatenating that path with
yes.
With what is that? Slash all.
Yeah, the one from this.
Oh, okay. So you have to concatenate both. Okay, I got
Yes.
it. Format string. Okay. So read CSV, right?
Yeah.
Read CSV. Okay, got it. I got a format string and yeah.
This should also work. Give the path plus the file name. Okay, we will start at 8 p.m. PST.
Okay.
Yeah. So Guru, is it working now?
Yeah, right now, yeah, after restart, now it's working like you wanted to run that the right now like the data frame and then dot head. So right now we just ran the
Yeah.
head, and then we need
Okay,
to
so you are able to run the first cell and import is going through. Okay, good.
yes.
Oh, okay. Well, now you remove the format string, is it? Okay.
Yeah, this is another way to
Yeah,
do
I
it.
got it. Yeah.
Okay, nice to see 12 people have set up their environment. So that is good. There are still a few more. So, oh, that could be just myself, Chandar, and Rahi. So,
Yeah, yeah. Let me end the poll so that we can get the names.
okay.
Kyle, on the one, could you skin? Where is the next part? The rep path on top. This one I'm not seeing the lab store.
You're not seeing this?
1 second. The all books. This lab 2 only, right?
Yes. Are you not seeing this file name?
Oh, okay. 1 second. Let me see. Homework. Is it bottom? Because I'm in lab 2 only. Lab. I have the rep path, but not the all.
I can, if not, let me just share it. But it should be in the first markdown cell.
Yeah, homework string manipulation I have. Data set. What do Asian religions have? And then about the data set, it's all links to them.
Then
Oh yeah,
link to the
sorry, I got
CSV
it. I
file.
got it. I got it.
Okay.
Yeah. Sorry.
Sorry, can you mute people? There's a lot of background noise. Thanks.
Yes, sure. Hello, Harleen. Harleen, am I pronouncing it right? Okay. Then Jay Krishnan, are you able to work on the lab?
Oh, no, lab,
Sorry?
I'm still doing it.
Okay, good. Hello, Madhu. Please let us know if you're facing any trouble.
I'm just facing the trouble on the renaming thing. Maybe you can explain with the team. No worry.
How you would rename?
Actually, I did. I went into the documentation somewhere. I found that df.rename. Then I put the column equal within bracket. I put a single quotes of the old name and then colon and the new name, comma in place equal to true. Something like that. Tried. Maybe I'm connecting. I'm viewing. I'm not able to copy paste because the one I'm seeing from a different screen, the Zoom link, and I'm working with my another laptop. I cannot copy paste.
Okay.
Yeah. Anyway, you can explain later. Nobody.
Sure. I mean, we have covered this in the previous lab. So,
is it? Maybe.
Yeah.
So
okay.
I'll refer that.
Yeah, sure. But this is all it is. I think, even if I might be getting the syntax wrong. So.
Is that simple?
See. I think you have to say columns.
Yeah, that's
this.
what it is.
Let me check. Maybe got it. So it's just you specify columns equal
df
to
dot column,
and then you pass in a dictionary, and in the dictionary the key would be the name, and this would be the
I did it differently. df.columns.value 0 equals
oh yeah,
book
sure,
name
you could do that
underscore
as well.
chapter. Yeah.
There are multiple ways to do this.
Yes.
Oh, column. Yes. Okay. My bad. It's a typo.
You can verify what
worked.
parameters you need from here.
But still give me the same name. If I run with the head. Oh, if I print the head, it will bring the old one?
No,
I need to store into another variable.
Yes.
Yeah, okay.
Or you have to do in place.
Yeah, I can store into a different variable.
So tail is like a descending order of the data set, is it? Head and tail.
It will print the last few rows.
Oh, okay. When I say head, first few rows, and okay.
Yeah.
Got it.
It's just like Unix. Yeah.
Oh, okay.
You're listing a file. It's a head, tail, cat.
Yeah, it worked. Okay.
Okay, so I think okay, I think we can ask participants here. Would you like to continue working, or should we move on to the next lesson? We could I think we can
move on to the
continue.
next lesson.
Yeah, we'll move on to the next lesson, and after tidy data we can spend some time again working on lab. So let's move on. Okay. Right. So tidy data, I'd say, is the most probably the most important lesson in this series, and it is based on the paper written by Hadley Wickham called Tidy Data. Now, Hadley Wickham is a biologist and statistician who has contributed a lot of several packages to R, the programming language, and he has, and the set of packages are together called Tidyverse, and he has contributed a lot to how you should structure data specifically for data analysis. And he's also contributed ggplot, which is a ggplot2, which are like visualization libraries, which have some we have the the counterparts in pandas as well, and matplotlib, and generally the plot style that we use in support vectors is ggplot. So and this paper gives a standard way of organizing data values within a data set. So so when we start, okay, so let's start with this quote here. Happy families are all alike, but every unhappy family is unhappy in its own way. So this we can compare it to data sets where a tidy data, it is of one standard format, while messy data can be messy in so many ways. So to arrive at tidy from a messy format to tidy data is what we'll be looking at in this
Kyle, could
lesson.
you increase the font size if possible?
Sure.
Thank you.
Let me also close this. Is this better?
Yes.
Okay. So to get started, we will look at again a subset of the Wimbledon data. So here, let's say we have data in this format. We are going to look at different ways we can organize this data, and the physical layout is what is referred in the paper as a structure or a data structure. So here we have this information, and how do we put it into a table? That we can do it in multiple ways. So one way would be to have represent data like this. If you remember yesterday, Srirang mentioned that we can have year as the index, making sure that there are no multiple years in the table, right? So and if we want to do that, this would be the structure that we can follow, where we have every year as one observation, or basically one row, and we
Well, we
have
can
all
have participant name also as the first column, maybe. Just just
So
the
the
uniqueness.
yeah.
There's multiple ways to skin the cat.
yeah. So this would be one way of doing it, right? So and here we have the Australian Open French. We have the tournaments here, and we have the years here. So this is one way of doing it. And we could also flip it when we could transpose it and have the years as the column names, and then the tournaments here. But even though this may look neat, this is still not considered tidy data. There could be an issue that could make this look a little bit more untidy. And that case would be, let's say here we are trying to record the winner of a particular tournament on a particular year. Let's say I want to also add the runner-up of that tournament. So how would we include that in this particular structure? It becomes a little messy, right? So we may need to add another column where we say 2019 winner, 2019 runner-up. Or we need to add an additional row where we have Australian Open winner or Australian Open runner-up, right? So we'll have two rows and then two columns. So the way we would have to modify the structure of the table to accommodate new information makes it very messy, right? So how would we standardize creating a structure for a table? that would make our make data analysis more easier, or even adding more information to it easier. We will see this in this lesson. So when we talk about the semantics, or just what are the core ideas when we talk about a table, we have three things. We have a variable, we have values, and observations. So when we organize a data or a table, we would want to have the data set defined in this way. A data set has variables and its realized values measured across observations. So what we would want to have is, we want to have variables, its realized values measured across observations. So a variable is what will take multiple values, and we are measuring it in observation. So let's just come back to this table. Let's try to identify what are the variables here in this table. So anyone would like to take a stab at this? What are the variables that we have in this table?
Year.
Year is a variable. Yeah.
Yes, year is a variable. Then
I mean, there are many. Year is one, the player is one, and the tournament is the other.
Why do you want to do it on the transpose one? Before transpose is better, right? Or you want
sure.
Yeah, this is.
I mean, anyway, as Srirang mentioned, exactly, there are three variables in this table, or in the table before, right? So we have the year.
Yeah. Okay.
The tournaments is another variable, and the player is another variable, right? So actually there are three variables in this data set. However, they are arranged in a way that it is not very intuitive, right? So when we talk about tidy data, we want to make sure that okay, let's say we arrange the table like this, right? We have year, tournament, and winner. And if we arrange the table like this structure clearly identifies each variable, right? We see the year as one variable, tournament as another variable, and winner as another variable. And each variable is measured across one observation. So we have one observation, right? So this is what we would call a tidy data structure. And we'll see, so what actually encompasses a tidy data structure. It would be, firstly, each variable should be a column, right? So in this case, we do see that each variable is a column. Each observation forms a row. That is also true. We have one observation, right? And I could also, and the observation is for year and tournament. We could consider the year and tournament as the index, right? Or across which we are trying to measure multiple things. We could, in this case, just add another column and say runner-up and add more information. Or we could add another information, who were the, in the women's tournament, who won, who was the winner, or women's tournament runner-up. So now adding more data to this table becomes easier, or even if you want to add more rows, it becomes more easier. So this is what we would consider tidy data. And these are the three core ideas behind tidy data. We should have each variable as a column, each observation as a row, and each type of observational unit forms a table. So we'll see what this third one means later in this lesson. So, so data arranged in any other form is messy. So from the previous example, one observes that each row represents an observation. So the winner of one tournament of 1 year, right? So now that we understand what tidy data is, even though it looks very simple, it's very easy to identify. It might be a little difficult when we have a very messy data to actually identify which are the variables, I mean, which are the, and how should we convert it back into a tidy format. So let's look at some options that we have. So before we look at our other tool sets, let's look at how generally data could be in a messy format. So the first one would be column headers are values and not variables. And we've already seen that example here. This is one example where we have values of a variable taking up the column, the place of a column header. So we have column headers are values, not variables. We also have multiple variables are stored in one column. We saw that in string manipulation. Variables are stored in both rows and columns. We'll see examples for all of them. Multiple types of observational units are stored in the same table. A single observational unit is stored in multiple tables. So to deal with these 5 cases, there's generally just the most useful tools are just melting, pivoting, and string splitting. So string splitting we already saw. And especially in lab 2, we see this is one case where we have multiple variables are stored in the same column. So the 2 variables are book and chapter, right? So they should be in separate columns. So let's look at how we can do this. If you're familiar with Excel's or SQL's pivot, unpivot, then you're set. But otherwise, we'll just go over what pivoting and or melting and pivoting means in and how do
So
we do
what were
it
the
in
3
pandas.
things? Melting, sorry, Kyle.
Yeah.
Melting, pivoting,
and string splitting.
oh,
Which
string
we
splitting.
already. So these 3 tools are almost good enough for us to work with. And if there are more, yes, we've already seen most of the other tools that we'll be using, like concatenation, dropping, and all of that. So, so to explain the first, first case, we'll take this data set. Okay. So in this, can you identify first of all what this, without looking at what the description for the table is, can we guess what the table is what is the data set about? It is
looks
a
like
little difficult, right?
it is trying to it's a econometric some people, how many people of what religion are earning how much money?
Yes, correct. Right, even though it's not explicitly mentioned, but we can take a guess that is what it is. So we have different income brackets, right, of and we are trying to measure how many people fall under each of the income brackets, and we're trying to measure it across religion. So what are the variables here? Does someone want to take
and religion and income brackets.
Number of people.
Religion and
So,
income brackets are the variables, right?
I mean,
those are the
number
2.
of people
There's
too.
another one. Yes.
Number of people too, yeah.
Number of people.
Third one is the number of people that fall under this, right? So if we want to rearrange this, what we would ideally want is we want to convert all these rows, I mean all these column headers into its own column, right? So we would want religion as one column, income group as another column, and then I'd say population, we can call it, right? So population would be the third column. So the way we would do it in, if you are familiar with Excel, this is exactly what you get after doing a pivot, right? Like you would, this is pivoting. So what we want to do is we want to basically put it back and melt or like make the data into a very long form. So this is wide form data, this is generally, we call it wide form, we're going to try and make it into a long form. So, so this is what we are trying to do. Here we have one variable, we have the other variable, and we have the third variable here as the values. What we want to do is we want to make sure that we have the variable A here, and we want to put the variable B, and we want to put the variable C. Is this clear? Or does anyone have any questions at this point?
Transpose, we are doing transpose or what?
No, this is not a transpose. This is called melting.
Oh, okay. So A, B,
This
C.
is unpivoting actually.
Yes,
Okay.
unpivoting.
Got it.
So why it is repeating? So under A, you see that first column is there. Then again,
So
I just want to see the logic behind it.
So we are trying to, in this format, A0, B1, and C4 are, they belong to one observation, right? When we're doing an unpivot, or in pandas speak, melt, we are basically trying to bring A0, B1, and C4 in one single row. And that is why there will be repetitions.
Correct. Every three is becoming a row there. Every
To
three.
understand the observation, when you say A0, in alphabetic order is 0 after 1. What is the relation on A0 next to B1 and C4 to make it a single?
Let's just
Is
assume that they have no relation.
ABC.
These are just,
ABC is the relation. A after B and C. Then they're choosing that to make it in order. I mean, there is some observation. You say A0, B1, and C4 in the same row, right? On what basis you consider? Because of the alphabetic order? ABC?
No. These are just some random names, just to make you just to show as an example. This is a dummy data.
Okay.
So
in the real time data, if you see something with apple, orange, and then they will row into a fruit row like that.
I think the previous example you showed, right, that itself explains it. If you see that religion, and basically if you have religion of Buddhist along with an income group of that 20 to 30, for example, that the number is 30, right? If you see Buddhist and the dollar 20 to 30K, that intersection is having a number of 30.
Okay.
So those three form an observation. That is what she's trying.
And that becomes actually a row when it becomes unpivot.
Okay.
So just like a triangle that it is ends up becoming like a row. With this 30, 20 to 30 becomes a row.
So
religion, population, and income.
Okay.
Yep. Makes sense.
Okay. Yeah. Good.
Right. So we have, this is the pivoted, this is the molten version. And so when we do a melt, this is what we want to get. So the syntax that we, here I'm showing another dummy dictionary, but let's look at this example itself, right? So if we want to melt this data frame, we are going to specify which column we do not want to melt, which are the columns that we don't want to melt. As in, here we want to keep religion as a column still, because this is a column. This is a variable, and we want to retain this variable as a column. Now, the remaining columns are the ones that we want to melt. So here, if we say ID variables are the ones that won't, get converted into rows. So specifying that here. Then we say in variable name. So the rest of it will get melted, right? So the other variables, all of them are going to get melted. And so what we ideally want is we want two more variables. The first variable is we want the column income, and the second is population. So to specify it, we specify variable name, variable name, which is income range, and the value name is the frequency, right? So when we specify this, we will get the melted version. Okay. So let's move on. So this is one method of tidying up your data. So the next issue that we would encounter is multiple variables stored in one column. So we've already seen this. Yeah, sure.
A little bit on top on that call, you said that variable name equal to income range and value name is frequency. These are the names which we gave, right? I mean, it was not in the data set, right?
No, yes, these are the names that we should give.
But
Variable
how
name.
does that melt? That is what I just. So anything apart from ID where they get melted, is it?
Yes.
That's right.
So
yeah, anything. That's exactly like what Excel does, right? If you say pivot on a particular column, everything else is pivoted across that column.
But this is not pivoting. This is unpivoting.
Unpivoting.
Yeah.
Because
yes, unpivoting. Sorry.
My question was like this method call. I understood when you said ID where you retain the religion, but rest of the columns, how did they got merged?
So the rest of the columns, they will get converted into. So the rest of the column headers will become one single column. So this will just get transposed, like transposed and duplicated. So when we transpose it, so this is what you call variable name, var name.
So it will be
specify.
like agnostic, 10K, and the frequency against that will become one row.
Yes.
So a question there is, I think you probably answered that. I'm still trying to understand. How does it know if you go down? I understand, go down a little bit. If this is your example, the melt. Yes, okay. So yes, there is a clue that don't touch religion, and religion is one of the column names over there. How does it know what is frequency out of that and what is income range actually? What I meant to say is that there are values just everywhere. How does it know that take these and arrange these to be frequency and take these and arrange them to be income range? It could have been swapped too by mistake.
Okay. So what you specify for variable name would be the column headers.
Okay.
Okay. If the column header is the variable that you want to, basically melt, right?
Okay.
So
that's a clue there.
Yes. So the variable name should be the column headers that you want to melt, and value name should be the values in the table.
Oh, perfect. Similar to the pivot where we give that column name and the values.
Yes. Right. So
can you do a PD dot columns 0 when you execute it? I just want to see. No, before this, the one cell before that. One before that. After reading, I just want to see how the columns look.
After reading.
In that population,
this
yes,
one?
Here.
Okay.
Describe
so actually, yes, I have done that here. pd.pdf.shape will give you. This is 18.
And what is the first column? I mean, I just want to see the first row. I mean, what is the name of the columns?
You can
in
do a
PDF.
head on.
Okay, let me just run everything from till here. Okay. What do you want to see?
The column names. Oh, okay. So how does it know? I understood religion is one of the column names. How does it know what is income range and what is population?
So yeah, everything else, it is going to melt, right? If you want, let's say you have So religion is the only column that you do not want to melt. So you specify in IDVARs. If there is another column you don't want to melt, you specify that too here. Okay, you'll specify that as a list. So that all the remaining columns that you want to melt will be implicitly taken. So since
it
you
will be implicitly
mentioned,
taken because the process of melting is automatically creating the next two columns.
Yes.
If
so
the data
all
was
the columns
organized
that
in a different way, if the data was organized in a different way, let's just say population was as the header, instead of that less than 10K, 20K, there were population up there, and then income was inside of it. Then you would swap the columns.
This. Yes.
Yes, got it. Okay.
Anybody else has a question on this? This is the only, confusing part of the lesson. Otherwise, it's going to be simple.
Frequency is going with the 2712, the complete row of, and what order is going?
So we have 10 under 10K. So anything 10K and religion, everything will, that would be these values. So agnostic under 10K, 27. Atheist under 10K, 12. Okay.
Okay.
So from an 18 cross 11, we go to 180 rows across 3 columns. So we do see that there's going to be a lot of duplication of values here. This is not the most date efficient way to store, but however, this is the best way if you want to do data analysis. So the next way would be multiple variables stored in one column. So we already saw this example. Actually, this is going to be two things put together, two issues in one. So okay, let's identify the issues with this table. Firstly, let's just read what this data set is about. This data set comes from the World Health Organization and records the counts of confirmed tuberculosis cases by country, year, and demographic group. So we are counting the number. It's a number of tuberculosis cases. And how we are measuring it is by demographic group, and it is broken down by sex and age. So we have male, female. So we already saw this example in string manipulation. A demographic group is a combination of sex and age. So if we see the data set, we see country, and then we have all these demographic groups as columns. So what are the issues with this table and how can we fix it?
Gosh. I mean, it's a sex and the gender and the age is mixed up. And
yes.
and in the same thing, even the male and the genders are mixed up and the ages are mixed up too, actually.
Yeah, that is one. And the second issue? One issue is where we have the demographic groups are a combination of two variables, which is sex and
right. But then the other one is even the genders are mixed up, actually.
Genders are mixed up, as in what does that mean?
No, okay. Genders are not mixed up. I would say that gender plus genders are, well, right. Genders and age are mixed up, correct.
So that is one issue. The second issue is that, again, here we have values as column headers, right?
Right.
So the first step would be to make the column headers
split, right?
No, firstly we'll have to melt it.
Okay.
We're going to melt and bring this whole thing is going to be, we're going to call it demographic group. This is one variable actually. This whole list of columns, they're actually a variable. So what we would want is country, demographic group, then tuberculosis cases. So the first step would be to melt this in so that we have 3 columns. And once we have those 3 columns, then we are going to split that demographic group column into 2 variables. That is gender and age group. Right?
So the columns, ultimate columns would be country, gender, and demographic group.
Country, gender, age group. And then
count.
Yes, that is what we would want, right? So so we've already seen both how to do this. We've seen both the tools that we require for this case, right? So let's just go ahead and see how it is done. Again, we're going to do the melting, and the melting, the one column that we don't want to touch is country, which is correct. The rest of the columns, I've just put it as column, but yes, the better way would be demographic group. Okay. We rename it to demographic group. Just run everything. And then this is cases. Okay. So from this point onwards, what we would next do is we are going to do string splitting, right? We're going to split it. Here's the solution for the lab as well, right? So we're just going to split this column into 2 columns, and then put back that column into our data frame, right? So we're going to have country, sex, age group, and then cases. So this is the second type of issues that we would face. Now the third one is variables are stored in both rows and columns. So let's take a look at this data set. So this is a weather data where free, this is weather data collected from here, where free access is provided to global historic climate data. And here we are taking a subset. Again, we are looking at the New Orleans Lakefront Airport Station. And we have actually purposefully messed it up. So you will find cases like this, but you know, just to show it, this is a manufactured messy data. So we have Tmax and Tmin, which is the maximum temperature, minimum temperature. So let's look at this data set and let's see what does it, you know, what does it tell us. Let's identify these columns. What are these? What is this D1, D2 till D31?
It may be a place, a demographic in that area.
Duration maybe.
Where duration?
It's simply the day, right?
Day.
Okay. Time series day.
So year,
the 31, yes. 31 was a clue actually with a nan over there. Yeah.
Oh yeah, that's good clue. Yeah.
So we have 31 days, year, month, and we're measuring Tmax and Tmin. So this particular case, the heading tells us we have variables both in rows and columns. So can we identify the variables here? Obviously now station, year, and month, they are variables. What are the other variables?
Elements, the minor mics.
Elements is this a variable?
I think the max and the min are variable itself.
Yeah.
Correct.
Yep.
Yes. So Tmax and Tmin are variables. And what is the other variable?
The date, actually, the day,
Yes,
date.
correct. Yep. So we've got it. So we have station, year, month, Tmax, Tmin, and date, right? So what is the last variable?
Last variable.
Oh, no, sorry. Yeah, we've already identified everything. So now that we've identified these variables, we are going to see how we should do the transformations to bring it back to a tidy data, right?
Here's a question. So would you prefer to, instead of having 3 columns, would you prefer to just have a date column? Because that captures the year, month, and the day.
Exactly. Yeah, we'll see. That's part of the transformations that we're going to do in this section. So the first thing, yes, we are going to firstly melt the data frame. And what are the ID columns that we would want to retain?
Oh, so station we need to have, right?
Yes.
Station is one.
We also need year.
Yeah.
And month.
Right.
And we're going to firstly fix element also. Let's save these 4 columns, because this is what are the days, right?
Yeah.
So we're going to fix all these as IDs, and the rest of the columns are going to get molten. So melted. So how
Why
do
would
we
you want
do
to
that?
fix element? Why would you fix element?
For this step. So we're going to do it step by step.
Okay. Got it. You'll slowly melt it.
Yes. So this we are going to melt.
Progressively melt it.
Element is the reverse case, right? Where we have to pivot it.
Correct.
So the first we'll deal with dates. So that's why we're doing it. So here we're going to melt the data frame, retaining these 4 columns as ID, and the variable name is day, right? And the value name, I can actually, if you don't specify the value name, it will automatically just default choose value. It will just create its default column name. But probably a better one would be temperature, right? We can just say value name temperature.
Got it. I understand this. I like the clue that you gave, because Tmax and Tmin are already in long form, and you want to make them into wide form.
Yes.
Yes. Good point.
So what is that long form?
Yeah.
Long form is just this is a long form, and you want this. Sorry, this is the wide form.
Where you say that time series.
Yeah. And the long form will actually unpivot it and make more rows, actually. But in this case, the Tmax and Tmin is already in the long form. You want to take it to the wide form.
Okay.
Because it will end up becoming columns. The max and the min will become column. And when you take it from the row to column, that's the pivoting part. You want to take it to the wide form.
Yep, that's exactly what it is. So here we are, when we say wide form, it generally means that one of the variables is actually a column header, right? So and long form is just the tidy format, where we have all variables as columns. So now that we have done this part where we have day as a column, the next thing we want to do is pivot this, right? So we want to pivot this element column so that we have Tmax and Tmin as separate columns. So this is the case where we have variables are in both columns and rows. So now when we do pivoting, this is what happens. This is just the reverse of what we saw earlier. Maybe you can just spend some time just taking a look at it. This is what pivoting would do. It would basically create a column for all the different types that we have in the columns, column, and we're going to have A, B, and C as columns, and all the values would be put here.
Makes sense.
All right. Yeah. So now that we have learned what pivoting means, let's see how we can do it in pandas, right? So we have a molten data frame. Then we are going to say dot pivot. And again, we are going to identify what are the index columns. So which are the columns that you do not want to touch in the whole melting pivoting process. So the index, again, we want to specify the columns that we don't want to touch. So if we look at it, we don't want to move around these 4 columns.
Cool.
The two columns that we want to, pivot. So when in the case of melting, it was the inverse. Now you have to specify 2 columns to melt. So which is the column that you want as the headers and which is the column that you want as the values, right? So if I want Tmax and Tmin as columns, so I'm going to specify my, so I'm going to specify my columns as element and values as value. And which is basically the temperature. So when we do the melting, this is what happens. Okay, so the index values are kept as it is. They are actually converted into indices. Then we have Tmax and Tmin. Okay, so let's, so what we would probably want to do is, so indices they're not repeating. So you'll have to do something called reset index, which will make, I'm getting some echo. Could you please unmute?
Dilavara, can you unmute?
Yeah. Okay. So if you see, if we do a reset index, the index becomes just natural numbers. So we have, and the rest of the indices become columns themselves. So if we do that, now we can see that we have data in somewhat a tidy format. Still, there is some amount of processing that we could do. And just as Srirang mentioned, one thing we would want to do is, hey, year, month, and day, they need not be separate values, separate columns. We could actually put them in one column and call it date, right? So it becomes easier for us to work with, and this helps us work with time series, right? And we can use all the time series functionality of pandas later. So we will not go through this in too much detail because actually it says previous lab, but we will cover like daytime manipulations in an upcoming session. So these are the steps that we are performing, and once we do this, we will come up with the tidy data, and so these are some steps, pre-processing steps, and finally we get date, station, Tmax, and Tmin. Okay, so right. So the next case we are going to see is multiple types of observational units are stored in the same table. So this is where we'll see, there could be a case where actually the data that is contained in a single table could be split into 2 tables. So this is
the case of normalizing it, probably.
Yes, the case of
normalizing. Yeah.
So here we are going to look at a data set, the Billboard data set. So the Billboard data set records the date of a song first entered the Billboard Top 100. From this date, the song's ratings are tracked for 75 weeks. It also contains information about the artist, song duration, and the year it was released. So let's take a look at that data set. And so it has 317 rows and 81 columns, right? So that itself is like a warning sign. Why do we have so many columns for such a simple data set? So let's, okay, since it has
Are these
81
real? Are
columns.
these real data sets or are these cooked up? Are they made messy?
I think this is probably a real data set.
Okay.
Because if it has week 1, I don't remember. Maybe I cooked it up. I did it
No
2
worries.
years ago. So
no worries.
Yeah. So if we let's take a look at this data set. Now, since it has so many columns, I have sort of transposed it, and we're just taking a small glimpse of the rows and columns. So what I've done is transpose. So you'll see all the column names as the first row and the observations along the side. So you can just probably tilt your head a little bit so you'll get an idea of how the values are. So now we see we have year, artist, track, time, date entered, then week 1, week 2, week 3, and we'll have 75 weeks, right? So and across that we are measuring the ranking of that song in that week. So let's say this particular song, Baby Don't Cry, entered the Billboard Top 100 with the rank of 87. Then the rank kept increasing, and then it went back up. So, and finally it left the chart altogether, and we have NaN values, right? So this is this is the data set that we have. Right. So can we identify the issues with this data set?
Surely the weeks should be the one of the columns. It should go from long form to wide form.
Exactly. So that is the first one. So we'll look at, once we get it to that stage, we'll look at the next issue. So first is, let's gather the columns, right? And the ID variables would be all the variables that we don't want, then week, and we're going to call the value name rating, right? So now we have a somewhat tidy data, but there is an issue with this data, because while actually we are trying to measure the track for an individual track, what was its rating. Apart from this information, we have other track details that need not that doesn't vary with the rating, and that is the artist, and the time of that, the duration of that song. So these two details, they're just getting repeated multiple times without any effect. They don't contribute much to this particular table with ratings. So what would be the best way to do this is, like, we separate this table into two tables, where one table holds the ratings for the song, and the other table holds the other information about the song itself. So so that would be just two tables, and just splitting it across two tables. So the reason why we would do this is, we have 75, like there are 75 weeks, and each song's information gets repeated 75 times. So to do that, firstly, we are separating out this information: year, artist, track, and time. So we are taking a subset of this data frame, right? So we see that it has so many rows, right? So what we could do is, we just simply drop the duplicates. So if we say drop duplicates, so we get each unique row is retained, and we have a total of 317 rows, which is we have 317 songs. So we have the song information in a separate table. So Billboard songs DF will be that, and then we'll have another table called Billboard ratings, which is the original data frame minus this information. So let's do we are doing some pre-processing here for Billboard songs DF, right? And we are basically creating an ID. So we are creating an ID column for each track. And so it's basically creating a foreign key and,
primary key. Yeah.
Yes,
That's
primary
right.
key. And so we are trying to relate the two tables. So once we do that, here's the original data frame. And finally, the data frame that we have is we have an ID for each song, and we have the date entered, week, and rating in a separate column, each columns, and we have the ID. So this ID relates to the other table. So now there's some more manipulation we could do, and that is firstly the string manipulation, where we have week 1, week 2, and week 63. And so this would be better if they were just plain integers, right? So we can do some string manipulation to remove these that unnecessary row. And then
Can you go back a little bit?
Yeah.
It's the weak part cannot be construed. So imagine if you started saying, if you started everything, is this week per year or is it week per?
No,
what I'm trying to say is that
what week here means is, let's say a song enters the Billboard that top 100
number of weeks it stayed. Got it.
Yeah.
Yes.
So week 1 is the first week from counting
it entered
from
the billboards.
Yeah.
Got it.
And then from then we measure till 75 weeks. Now the song may not be there for 75 weeks at all. It
Correct. It gets an answer that case. Yeah.
Yes.
Got it.
So this is what we are measuring the rating with, against the week. Right. So there's another way. If we do some more date manipulation, we can get the rating of each song on the particular date, like on a given date. So we like calculate, say, from the date entered, let's say date 63, let's say it entered in 1999 September 11th. Okay, I think September 11th. Then we would 63 weeks from then, what is the date, right? So we can convert these.
That's what I was saying is, can you construe the weeks from the dates?
Yes, we could do that. And so using some more data manipulation, we can get that working. So we'll go into data manipulation later. So what we do get here is the ID, rating, and the date of the rating. So then we have the last and final type is a single observational unit is stored in multiple tables. So we'll go back to our Grand Slam data set. Let's say we have two types. We have the winners, the men's tournament winner and the women's tournament winners, right? But we have them across two tables. Your tournament winner. So this is for women's tournament. This is for men's tournament. Now, but both tables are actually measuring the same observational unit, right? So in the year 2022 Australian Open, who won? It could be an either, we could put this in the same table. So for that, but the only thing missing is that we need another column that
Gender,
specifies
yeah.
which gender it is. So we can specify the men's or women's tournament as a separate column. So to each table, we can append one column, right? Specifying which gender the tournament is meant for. Once we append that separate column, and to add a column, it's just very simple. You just say the column name and the value. If you specify a single value, the value gets repeated to all the columns. So it's a simple way of adding a single scalar value and apply it to all the rows. So you can just add a separate column in both tables, and finally put it together in concatenate those two tables. So then we have the whole of the table information in one table. So with that, we end the tidy data lesson. If you want to read the paper, we have a link to the paper here in the top of the notebook. So
Nice.
you can refer to it as well. So let's take a short break, and maybe we can just work on the labs and finish this session. We can continue the remaining lessons tomorrow, because this was a heavy topic. We can continue it tomorrow. So you can continue working on the lab. So let me introduce the last lab session for today. I mean, for this.
Tomorrow is the last day, right? Tomorrow is the last day of this.
Yeah, tomorrow is the last day. So is this the solution? Okay, let's go to solution. So in lab 3, actually there's if time permits, we'll have one more lab, which is the California data set. So let me just run this and show the outcome.
Are we going to touch your time series by any chance?
We will look at date time manipulation, but not time series.
Not time series.
We won't be looking at time series models or anything. Just how to manipulate date time, we will look at it tomorrow.
Correct.
We have two more and one pre-processing lesson, one or two pre-processing. How just depends on the time. So this is the this is what we are trying to achieve by doing a lot of data manipulation. We want to bring the data from 3 different tables, which these tables are directly taken from the Gapminder website. So let's just click this and let me open that. Okay, so this is the Gapminder website, which you might have read this book. Just forgetting the name. Oh God. Okay, I'll get back to you on it. So there's a book which just gives us some information about the actual. So this website has collected data on income levels across countries, and there are actually many more data sets and many more visualizations that help us understand the current state of the world today.
Oh, right? You mean factfulness?
Yes, exactly. Factfulness. Yeah. Okay. Yep. Factfulness. So you would have seen these visualizations in that book as well. So if you see, if we just move this around, we see what we see is the life expectancy versus GDP, right? GDP per capita for each country. And there is some more information as well. And the size of each bubble here tells us the population of that country. The color of each bubble tells us the continent which the country belongs to. So it's a very nice visualization that tells us how the uh, the world's population has increased over time, the GDP per capita has increased, life expectancy. So it gives us it gives a lot of information packed in this very beautiful visualization. So we see, and we can, India is here, China, and I think US is over here. See how the populations are growing, and we generally see the life expectancy improving and the income GDP improving. But we do see a significant, clustering of like, especially we see African countries on the lower end of income GDP and life expectancy. But generally, we do see an upward tick, right? So this is a very beautiful illustration, and you can spend some time just, admiring it in your free time. So we have a link to this in the homework notebook as well. Right? So our goal would be to basically we'll have three separate CSV files, three separate data sets. Each data set for one type of information, we have income, we have the population, and we have life expectancy, right? So these CSV files, I think, are in the GitHub repository. You'll have to load them. So once you load them and eventually, like, this code to create the visualization is already there, but all you need to do is make sure that the data comes into this final format where you have country, year, income, population, life expectancy, and the continent. So if you have the data in this tidy format and brought into properly done, this visualization would work. So we have created an Altair visualization to sort of mimic the Gapminder visualization, right? So Asia, so if the data is properly transformed, this visualization would work in the end. So this is the third lab, which is going to be a slightly more slightly more difficult and challenging lab to do, because you're going to have three data sets and you have to use all the techniques we learned so far in the tidy data lab and all the labs before, to pre-process and to sort of wrangle with it and bring it to a state that can be used for this visualization. So that would be the third lab. So you can now start working on the second lab, and if you're done, you can go ahead and start with the third lab. So that's it for today's lessons though. So I'm going to leave this, I'm going to leave the screen on, and anybody has any questions?
No, just the philosophical question. So the more and more we see that when you access these data sets from World Health Organizations or various places, they may not be structured the right way that you want. And that's why data cleanup is so important in AI, ML, is that data that is coming has to be, and that is a part of the pipeline in the you would probably with Jupyter notebooks probably clean it up a little bit. But then when all of this is done, you will actually would need to create a pipeline when if streaming data is coming, or you need a way to put this in to clean this up the way we are cleaning it, but that cleanup has to be happening at runtime also.
Yes.
Kyle, in the real world, still we are using this similar thing for data wrangling, or they use any different approach? See, this may be a old one, I guess, right? What is the current technique they're using? See, because so many things are changing, right? Transformer, all those things, a lot of new things coming. We are not using the neural network now, right? They're changing to different things. Similarly, for the wrangling, data wrangling also is a new technique as we're using in the industry.
I mean, there could be a different libraries to do this, but eventually you will still need to do this, right? Like maybe like for example, Tableau is there. You
Yeah,
could
the
probably
visualization.
import.
Yeah,
You could import your data into Tableau, and maybe pivoting and melting could be an easier concept there. But eventually, you still have to do it. You
maybe
still have.
simplified the process, but still the process is required. That's what I'm trying to say.
Yes, the process is
Okay.
still there.
Okay, thank you.
So you would still use essentially you could use Apache Spark, you could use Flink, Kafka, whatever that is, to stream the data. And once the data starts coming, you would still use pandas in real time. That code will kick in and clean up your data, and then the data proceeds further to ML or
Yes.
ML. Yeah, makes sense.
So in an upcoming course, we will be looking at how to do certain of these data pre-processing steps in at scale. So if we have a very large data set, how would we do this pre-processing? How we can parallelize some of these steps. So that would be part of the MLOps course that will start.
And that will probably focus on array, probably.
Yeah.
Mm-hmm.
Yeah, but internally we can use the same pandas, whatever constructs Kyle has explained. Within Ray also we can use it.
Correct. Exactly. Ray is just a processing framework, job processing framework. So you could use anything inside of that. Correct. Makes sense.
Thank you, Kyle.
Great.
Thank you all. Thank you.
I'm going to peel off too. I'm going to peel off at this point in time. So, Kyle, are you saying we have tomorrow and day after also? No, Sunday is the day off, right?
Yeah, just tomorrow. We have one more session.
One more session.
Yeah.
Because you at some point you did mention that we might have two more, just one more.
I did just one more.
Yes, it's one more.
I think maybe Asif mentioned it, but let's see.
No, it is only one more for this data wrangling. And then I think Asif is going to have sessions on introduction to machine learning, which is another series. I think he plans a series of 4 classes on it. That is going to be the coming week. But the data wrangling will be over with one more session.
One more session. Got it. Okay. Perfect.
Thank you.
Now, I know that Jorge Cardona mentioned polars and parquet, the column formats. It's not PARKET, right? It's PARQUET, correct? Parquet is PARQUET.
Yeah, that's right.
Yeah, it's a parquet.
So I'm not familiar with
but that is for storing data, right?
Correct.
Doesn't.
But the thing is, yeah. Okay, got it.
Okay, so yeah, I think that's it for this session. You can continue working on the lab, and if you want, you can stay back to figure out the setup in case you have any issues, or else, that's pretty much it for today. Maybe we can stop the live streaming, Chandar.
Unfortunately, I don't know how to do it. So Asif told he will do the post processing of getting rid of the pauses and other things. So till the Zoom is on, the streaming will be on.
Okay.
Okay, we need to call him then.
It's okay. He said he will handle it later.
Okay, I'm just seeing a lot of messages from Jorge. I don't know if I'm pronouncing it right. Yep, thank you, Jorge. Sorry if I'm murdering your name.
I didn't see that message. Where is it?
Oh, in the Zoom.
Yeah, I'm just seeing the messages in Zoom. Yeah.
Okay.
All right. I'm peeling off. Thank you. Have a good day.
Yep.
Bye.
Sure. Yep. Bye-bye.
Bye.
Yep. Let's
So Kyle,
end the meeting. Yeah.
yeah. So tomorrow you have the credits, right? You start the meeting around 7:20
Mm-hmm.
because if you start it beforehand, people will join slowly.
Okay.
You have the credits, huh? I also have, but
I
you have it
mm-hmm.
license.
Okay.
Yeah. Today Asif has started.
Mm-hmm.
Oh, tomorrow you start. If not, then let me know.
Okay. Sure.
I think tomorrow Asif said he will join, but anyway.
Oh, okay.
I wouldn't be there.
I know. Even I will be busy, but I'll join from my mobile.
Anyone else in the group has any questions right now, or should we end the meeting?
End the meeting. Good night.
Yep.
Okay. Fine.
Sure.
Thank you.
Thank you. Bye.
Okay. Thanks, Kyle. I'm stopping it.
Yep. Sure.